This is a demonstration of the OptimEyes VisualEyes Scripting Tool. In this video, we'll demonstrate how scripting can be used to automate quality control inspections. To create our script, we'll first open the VisualEyes Script Tool. For a real-world application, the first thing for the script to do would probably be to acquire images from a camera. In this example, we'll load them from files instead. To do that, we'll open the File Manager tool. Since we want to perform the same operation on a number of files, we'll go to the Multi-Open tab and select the folder where our images are stored. The images that we want to operate on are named floppy, a number.bmp, so we'll enter a filter to ensure that we only open the files that we want. When an image is opened, by default the image in memory is addressed by the file name. Since the name of each file will be different, we want to override that behavior and ensure that for every file, the image name in memory is the same. We'll click Apply, and as you can see, the first image has been opened, and then we'll click Record Script. As you can see, a multi-open step has been recorded in our VisualEyes script. Now we'll draw a rectangular ROI on the image of the floppy in the area that we want to inspect, in this case, the label area. Each time the script runs, we want this same ROI placed on the image. So we'll save the ROI to disk, and I'll just overwrite this existing file. And now I'll reopen the same ROI and click Record Script. As you can see, an Open ROI step has been added to the script. When we run this script, we'll want to perform several operations on each of the images in our folder, but we only need to load the ROI once. So we'll add a startup item to our script and move the Open ROI step into it by right-clicking and dragging it. That way, the Open ROI step will only be performed during the first pass through the script. Because this is probably not obvious, let me point out that when you run a VisualEyes script, the script automatically repeats until you manually stop it or it encounters a condition that causes it to stop, such as an error or, as in this case, a multi-open step running out of files to load. Since the floppy disk may not be in exactly the same position in every image, our next step is to align the ROI to the image. To do that, the first step is to draw line ROIs across the bottom and left edges of the disk. Our next step is to use these line ROIs with the Edge Finder tool to find the positions of the edges of the disk. I'll select the input image, Auto Threshold, and Find Falling Edges, which is where the image mask that's generated by the thresholding operation changes from white to black. The reason why I'm looking for falling edges instead of rising edges is because I drew my line ROIs starting from the white area around the disk and ending inside the disk. Feel free to do it either way, but just be aware that the direction that the lines are drawn needs to match which edge you have the tool search for. I only want to find the first falling edge, so I'll select 1. And I want to create a point ROI at the exact location of the edge, so I'll set Length of Found Edge to 0. In the Options dialog, I'll set some colors, set the ROI group number to 10. There's nothing special about that particular number, I just want to be sure that any ROIs that are found end up in their own group. And finally, I'll change the base name to Left. Now, when I click Apply, as you can see, a point ROI has been placed at the point where the line ROI intersects the left edge of the disk. I'll click Record Script to save this operation, and then right-click on the other line ROI to activate it. In the Options dialog, change the ROI group number to 11, otherwise the left ROI would be deleted when I found the bottom ROI, and change the base name to Bottom. I'll click Apply to find the bottom edge, and click Record Script again. As you can see, 2 Find Edges steps have been added to our VisualEyes script. Next, we'll use the Measurement tool to store the left and bottom positions in VisualEyes script variables so that they can be used by other tools. To do this, I'll click Point-to-Point Measurement, and then right-click the left and bottom point ROIs to activate them. As you can see, the positions of the 2 ROIs are now shown in the Measurement tool. To save them in script variables, I'll open the Options dialog, check Make Script Variables, and for Start Point X, enter Left, and Stop Point Y, enter Bottom. These are the names of the script variables that I'll create. With everything set up, I'll click Record Script. At this point, a script step has been created to create the script variables left and bottom, but since I haven't actually executed the script step, the variables haven't actually been created. I'll need them to be created before I can record some of the following steps, so I'll select Measure, and then click Step to actually perform the operation. At this point, the variables have been created. The next step is to use the ROI Manager tool to move the label space ROI, if needed, so that it's positioned correctly with respect to the left and bottom edges of the floppy disk. I'll go to the Move tab, and from the X and Y drop-down lists, select Left and Bottom, the names of our script variables. For this to work correctly, the label space ROI needs to be active, so I'll right-click it. We don't want to scale the ROI, so I'll uncheck Scale, and then click Apply. This sets up the relationship between the positions of the point ROIs and the label space ROI, so I'll click Record Script. The next step is to perform an edge enhancement operation in the label space ROI. If there are any cracks or scratches in that area, the edge enhancement operation will make them easy to detect. To do that, I'll open the Filter tool and select the Sobel filter. I want to perform the operation within the image itself rather than putting the output into a different image, so I'll select Floppy from the Output Image drop-down list. I'll click Run to perform the operation, and as you can see, since there are no edges in the label space area in this image, no edges get highlighted. Then I'll click Record Script. The next step is to analyze the output of the Sobel filter to see if any edges were found, indicating defects. To do that, I'll open the Histogram tool, and from the Action menu, select Add Histogram to generate a histogram of the pixels inside the active ROI, and then in the VisualEyes Script Options dialog, configure the tool to store the standard deviation of the pixel brightnesses in a variable named stddev. With the histogram tool configured, I'll click Record Script, and then, as we did with the measurement tool, I'll execute this step in order to actually create the variable. Next, we need to make a decision based on the value of the standard deviation. To do that, we'll add an if-then step to our script. Our settings will be if the standard deviation is greater than 12. The reason for the number 12 is that we found by analyzing various images of good and bad floppy disks that 12 works well for this operation. For different applications, the appropriate number will be different. Since the if-then step wasn't inserted at the bottom of the script where I want it, I'll click and drag it to the correct location. In an actual manufacturing operation, what we might do next is use the Serial I/O tool to tell a machine to remove any faulty disks from the manufacturing line. For this example, what we'll do instead is overlay some words on any images we find of faulty disks. To do that, we'll open the Text tool, select Draw in Image, choose a font, and then enter the words we want displayed on the image. Label damaged. We'll click Add Text, and then click in the place on the image where we want the words to appear. Then I'll right-click the text in the image to activate it, and click Record Script. As you can see, the text step is not indented under the if-then step, so I'll right-click and drag it onto the if-then step to move it to the correct position. If our machine vision application were controlling equipment, it would likely not be necessary to have the computer take the time to redraw the screen, since usually no one would be watching the screen. In this case, we want to see the script in operation, so I'll click Show Output. Now I'll save the script, and I'll restart OptimEyes and show you the whole thing in action. I'll open the VisualEyes Script Tool, reopen the script, and step through the script one step at a time. In a real-world application, of course, you'd generally click Run once and let the script run to completion instead of stepping through it one step at a time. We've reached the end of the analysis of the first floppy disk, and as you can see, Label Damaged did not appear on the image. Now let's step through everything again for the next image. As you can see, this disk has scratches on the label area. If you watch carefully, you'll see the point ROIs on the left and bottom move, and now the label space ROI will move too. This time, the Sobel filter operation clearly highlights the scratches, so the standard deviation of the pixel brightnesses will be much higher. As you can see, the words "label damaged" have been overlaid on the image.